Hello everyone. Today I'm going to talk about our recently accepted CVPR 2026 highlight paper, MINERVA-Cultural, which is a novel cultural video question answering benchmark. Our focus with this benchmark is on evaluating how well multimodal models reason over long videos across diverse global languages and cultures. Most of the existing video benchmarks suffer from Western and English centric bias. Existing benchmarks often rely on translated text paired with Western visual concepts. To address this, we created truly multicultural, multilingual benchmark, which features region-specific cultural events, questions, answers, reasonings, phrases, all in native languages, skills, and external links. We created over 540 videos and about 2,300 questions. Our benchmark covers 18 distinct global locales, and here is a snapshot of the dominant skill distribution across our benchmark, with object recognition dominating because every question requires visual cultural understanding. Our human annotation process was rigorous. We used two groups of local experts, curators and auditors. Curators wrote the questions and auditors verified them. We ran extensive calibration phases to ensure the hardness of the question and also to ensure the correctness of the question. Here is the core finding of our benchmark. Modern video models struggle significantly with cultural reasoning. We evaluated several frontier models like Wen, Claude, GPT-5, and Gemini 3 series of models. While human baselines hit 95% accuracy, our top performing model, Gemini 3 Flash, achieved only around 50%. That is a massive 45% gap between humans and the models. We ran different tabulations to understand these failures. First, with the addition of audio track, the performance constantly improves, and then with the increasing number of frames, the performance again improves, but eventually plateaus. Next, let's talk about error attribution. We looked at some of the um, performances of the model. Um, However, just looking at the accuracy doesn't give us a full picture of what is going on. Hence, we need to do a fine-grained analysis of errors. Uh, Towards this goal, we built a system of error attribution by analyzing model thought logs against human reasoning traces. The first step towards this was to process human reasoning, and next was to extract a evidence directed acyclic graph or DAG, where each node consists of just the evidence. It is important to notice that the evidences have a causal relationship, which is represented as a DAG, where some evidences act as prerequisite to others. For example, one must identify the athlete before identifying the state for which he plays. Next, we go iterate node by node or the derived evidence graph and map the evidence to their counterparts in model thoughts. We see in this example that the model is able to identify the athlete and the team correctly. However, it fails to localize the magazine and hence is unable to proceed any further. Next, we classify these into several error categories. So we carefully design six error categories: temporal localization, spatial grounding, attribute classification, spurious objects, reasoning, and external knowledge. Let's assume that the model stopped at a particular node. Normally, this would prevent a fair evaluation of subsequent nodes as the downstream states are dependent and corrupted by the initial mistake. However, simply stopping there would underutilize our benchmark. To solve this, we intervene by providing the model with correct ground truth information and continue, ensuring we can still evaluate its performance on the remaining steps. The impact of this approach is clear. With each precise intervention, the performance climbs. This tells us that these models aren't necessarily incapable of solving the whole problem, they are hit with specific roadblocks. Most of the errors that we see are mm, recognition errors. That is, 75% of the errors belong to the four class of recognition, and the remaining 15% comes from reasoning. This highlights that future efforts need to address the ability to recognize the objects from different cultures and locales. Thank you.